Okay, so on to the next example. Consider the power series, sum n goes from 0 to infinity, minus 1 to the n, x to the n over 2n plus 1. So again, we're asked to use the ratio test to determine the radius of convergence, so we're going to look at this limit, an plus 1 over an. So up here, I'm just going to write out what an is for a fixed x, minus 1 to the n, x to the n over 2n plus 1. And I'm going to give a formula for an plus 1 under this, which is just going to be minus 1 to the n plus 1, x to the n plus 1, over, and then if I plug in n plus 1 into the bottom, I actually get 2n plus 3. Okay, so this is equal to, then n goes to infinity, minus 1 to the n plus 1, x to the n plus 1, all over 2n plus 3, times flip an upside down, 2n plus 1 over minus 1 to the n, x to the n, take the absolute value. What cancellations do I get? The minus 1s I don't care because I'm taking an absolute value, and the x's I'll get a cancellation there. So this is equal to, then n goes to infinity, absolute value of x times absolute value of 2n plus 1 over 2n plus 3. But 2n plus 1 over 2n plus 3 goes to 1. So this is equal to absolute value of x times 1, which is the absolute value of x, i.e. L is less than 1 if and only if absolute value of x is less than 1. So that tells us that the radius of convergence is 1. The radius of convergence around 0. Okay, so what are the endpoints? Well, if we're around 0, then it's just plus or minus 1. We can go one to the right, one to the left. Okay, so check the corresponding series for x equals to 1. So just plug in x is 1, and that x to the n will disappear. And we'll just get sum from 0 to infinity, minus 1 to the n, over 2 to the n plus 1. Okay, then for x equals minus 1, the x to the n will now be minus 1 to the n. So it's a sum from 0 to infinity, minus 1 to the n, times minus 1 to the n, which will cancel for all n. Minus 1 to the n times minus 1 to the n is just 1. So this is sum from 0 to infinity of 1 over 2n plus 1. Okay, and as the question says, we don't yet have the tools to determine whether these series converge or diverge, but we'll develop them at a later lecture.